The most impossible exoplanets we've ever found. In the silent, sprawling dark between the stars, thousands of worlds turn. Most are variations on a theme: gas giants, rocky bodies, ice worlds. But some are different. They are the outliers, the anomalies, worlds that shouldn't exist according to our early models, yet they glow in the dark, waiting to be found. Beautiful, lethal. They don't just bend our rules of planetary formation, they shatter them, forcing us to redraw our map of the cosmos and reconsider what is truly possible. Let's get our bearings. When we say impossible, we're not talking about magic. We mean worlds born from extreme physics or forged in the crucible of unlikely celestial events. We're talking about heat that can vaporize rock, winds that move faster than the speed of sound, or orbits so strange they defy our gravitational intuition. These are the planets that live on the very edge of our understanding. Let's tour the strangest of them. Our first stop is TRAPPIST-1, a system that feels like a cosmic miniature. 7 small rocky worlds are packed incredibly close around a cool, dim red dwarf star. They are all tidally locked, meaning one side is trapped in eternal day, the other in an endless frozen night. It's a compact clockwork where sunsets are not an event, but a permanent place, a thin line between fire and ice. Let's zoom in on TRAPPIST-1e, a world roughly the size of Earth. Picture standing on its terminator, a ribbon of permanent, haunting dusk. The red sun hangs frozen on the horizon, never rising, never setting. Above, the stars are sharp and brilliant against a black sky. If life exists here, it may be balanced on this thin twilight edge, a fragile haven between a scorched wasteland and a cryogenic desert. Now, from the cold to the fire. Meet Kelt 9b, a star-skimming, ultra-hot Jupiter. This planet orbits so close to its searingly hot blue star that its year lasts less than 2 Earth days. Its dayside temperature reaches over 4,300 degrees Celsius, hotter than many small stars. The star's ferocious glare is so intense that molecules themselves, like hydrogen gas, are torn apart in the atmosphere. The night side, while still incredibly hot, is a place where the universe tries to mend what the day rips open. On a similar world, WASP-76b, we find a different kind of hell. Spectroscopic evidence suggests that its blazing dayside, facing a sun far hotter than our own, is hot enough to vaporize iron. Powerful winds, driven by the extreme temperature difference, then sweep this iron vapor over to the cooler, permanently dark night side. There, as the temperature drops, the iron may condense and fall from the sky, a literal rain of molten metal. If iron rain isn't strange enough, consider HD 189733b. From a distance, it's a beautiful, deep cobalt blue, reminiscent of Earth. But this beauty hides a terrifying reality. Its color comes from an atmosphere laced with silicate particles. And that atmosphere is anything but calm. Screaming winds race sideways at over 8,000 kilometers per hour, 7 times the speed of sound. Some studies hint that as silicates condense in the heat, they could create a rain of glass, slicing horizontally through the dark. Not all impossible worlds are hellish. Some are just complex. Welcome to Kepler-16b, a real-life Tatooine. Here, 2 suns rise and set in the sky, casting double shadows that crawl and stretch over the alien ground. While the planet itself is a cold gas giant, its existence proves that stable orbits are possible in a binary star system. It's a reminder that the sky is never simple. Now we visit 55 Cancri E, the diamond planet, or perhaps the lava planet. Early theories suggested its carbon-rich composition could lead to a crust of graphite and a mantle of solid diamond. More recent observations, however, paint a picture of a world with a dynamic surface. It may be covered in vast lava oceans under a broiling, thick sky. its heat pulsing like a cosmic heartbeat. The day side is an incandescent furnace, while the night side is stark and black, a world of extreme violent contrasts. From fire, we move to mystery. GJ-1214b is a hazy and secretive world. It's a steamy mini Neptune, wrapped in clouds so thick and high that they completely flatten its features. Telescopes can't pierce the veil. Is there a rocky core? A water-rich interior? We don't know. The clouds hide the surface from view, leaving us with a blank canvas, a planetary enigma. Where GJ-1214b is a mystery, TOI-1452b offers a tantalizing possibility. Evidence suggests this super-Earth could be a true global ocean world. Imagine a planet with no continents, no shores, just a single deep blue sea stretching from pole to pole. The pressure would build with every meter down, potentially creating exotic forms of ice not at the bottom, but deep within the liquid mantle. A planet that is mostly sea. Next, the planets that defy density, Kepler-51's superpuffs. These three worlds are enormous for their mass, so bloated and light they have the density of cotton candy. They are planetary ghosts. Gravity on these worlds whispers, barely able to hold on to their vast, billowing atmospheres. How they formed and retained these puffy envelopes is a profound puzzle. Some worlds have no sun at all. These are the rogue worlds, like PSO J318T522. Ejected from their home systems or born in isolation, they are cosmic orphans. They have no star, just a lonely, endless drift through the galactic night. Any internal heat from their formation slowly fades into the void. For these planets, the dark is forever. And then there's HD 10906b, a planet that challenges the very definition of a solar system. This gas giant is an extreme outlier, on a wildly distant and inclined path around its young binary star. It's so far out, over 700 times the distance from Earth to our Sun, that the word orbit stretches until it almost snaps. It may be a failed star or a planet captured from another system. So, how do these impossibilities come to be? You have to thread it all together. Gravity sculpts, heat forges, radiation edits, and chemistry colors the skies. These fundamental forces, acting under extreme conditions over billions of years, write strange but workable recipes for worlds we once thought were impossible. A planet's history is everything. Formation matters. Giants born in the cold outer regions of a system can migrate inwards, becoming star-skimming hot Jupiters. Cataclysmic collisions can remake worlds entirely, boiling away atmospheres or creating moons. Lost moons themselves can become independent planets. History leaves its fingerprints in every orbit, every atmospheric line. We find these distant worlds through patient observation. Most are found by their shadows. The transit method, where a planet passing in front of its star causes a tiny, periodic dip in starlight. Others are found by their gravitational tugs, making their star wobble back and forth, a method called radial velocity. And for a rare few, we achieve direct imaging, capturing the faint photon of light from the planet itself. Machines wait, measure, and whisper their names to us across the light years. But a word of caution is essential. Evidence suggests, models predict, instruments hint. Science is a process of refinement. Each new spectrum from a telescope like the James Webb Space Telescope can overturn the last headline. What we thought was iron rain might be a different chemical signature. A hazy world might reveal its secrets to a more powerful eye. That's not failure. That's science doing its job, getting closer to the truth with every observation. The ultimate lesson from these impossible worlds isn't that nature breaks its own rules. It's that nature uses all the rules all the time in combinations we have yet to imagine. Our list of what can't be keeps shrinking, while the universe's catalog of what is continues to grow. Let's recap the gallery of the bizarre. Compact families of tidally locked worlds. Star-skimming giants hotter than suns. Planets that rain molten metal and sideways glass. Worlds with 2 suns in their sky. Oceans of lava and planets of endless water. hazy, secretive steam worlds and cotton candy giants that are mostly air, lonely rogues drifting in the eternal night, and planets whose orbits are barely orbits at all. Out here, among these cosmic wonders, our own star is just another coin of light, and the concept of home is a faint, distant thought. Signals from our robotic explorers crawl back to us over years, carrying fragments of these alien realities. The cosmos turns, vast and unconcerned with our discoveries. And yet, we must look at them. In these extreme environments, terror and beauty share a border. They are a testament to the universe's boundless creativity. For now, we can only send our machines, our proxies of light and silicon. We return not with souvenirs, but with data, and with awe. We come back with stories, and in those stories, we expand our own world.